Hello and welcome. In this video, we are going to discuss how to reset the kth bit of a number and how to toggle the kth bit of the number. So let's get started. Consider a number 13. Its binary representation is shown over here. If you want to reset the fifth bit of it, that means you want to change that bit to 0. It's already 0 in this case, so it will remain as it is and you will get 13 as the result. If we take another example, suppose the number 22, its binary representation is shown here. If we want to reset the second bit of this number, so that is shown in the red color, that means we want to change this bit to 0. If we change this bit to 0, you will get this number, and this is the binary representation of number 18. So resetting the kth bit means that we want to change the kth bit of the number to 0. So how we'll do that? That we are going to discuss. Let's suppose the number is 29, and if you want to reset fourth bit of it, we are counting from 0. So this is the 0th bit, first, second, third and fourth. The fourth bit is shown in red color. If you want to reset this bit, you want to make this bit 0, for that you have to AND this number with this number, a number that have all ones except a 0 at kth bit position. So this number we want, because we want to reset the fourth bit. So fourth bit of the number should be 0, rest of the bits should be 1. So what we will do, we'll first AND this number with this number and you will get the result. Here keep in mind we need to perform the bitwise AND operation. So after bitwise AND operation, the kth bit will be reset as shown over here in red color, and the corresponding number is to this is 13. So if you reset the fourth bit of 29, then the resultant number will be 13. Similarly, in another example, if the number is 22 and if you want to reset its second bit, that is shown in red color, you will AND this number with a number that have all ones except a 0 at kth bit position. So here the kth bit position number is 0. So when you will AND it, you will get this number, and this is the number that is equivalent to 18 in decimal. Now the thing is how we can generate this number that have all ones except 0 at kth bit position. This we are going to discuss in the next slide. So how to find the second operand, that is what we are going to discuss now. So first of all, if you want to reset the kth bit, you will find a number that is 2 raised to power k. If let's suppose if you want to reset the fifth bit of the number, then you will find 2 raised to power 5, so that will be 32. I have shown it here, the number that is 2 raised to power 5. So you will get this number. Now I want to generate a number that has all 1 bits except the 0 bit at kth position. So for that you need to complement this number. You have to find out the ones complement of the number. So for ones complement, you can use this tilde operator. It's shown over here in the slide. Say that this number is s, so that means you have to find the ones complement of s. So if you find the ones complement of this, you will get the desired number. So you will find the ones complement and this number with the number whose kth bit you want to reset. This we are going to discuss in the program as well. So here is the program for that. So we need two numbers, one that the one we will read in variable a, another we will read in variable k. So we want to reset the kth bit. So for that we are generating a number that is equal to 2 raised to power k. So this line power 2 raised to power k will generate that number. Next two printf statements will print the actual number before the kth bit is reset, and the next line in this is the main line of this program. Here we are ANDing a. This ampersand is basically for the bitwise AND operation with the complement of b. So this is the desired number which are having all ones except 0 at kth bit position. So after ANDing it, you will get the desired result in a itself. So after that we are going to print it through these two printf statements. So here is the result for that. When you will execute this program, it will ask you to input two number. I have entered two numbers, 13 and 3. So 3 is basically the kth bit, third bit I want to reset. So after resetting the third bit of 13, I will get 5 as the result. So you can verify it. The next thing that we are going to discuss is toggling kth bit of a number. Toggle means we want to change the bit from 0 to 1 and 1 to 0. So here again I have taken the same example. One number is 13 and we want to toggle its fourth bit. So fourth bit is already 0. If you toggle it, it will become 1. So in that case this will be the output, and this number is equivalent to 29 in decimal. If we took another example, 22 is the number in this case, and we want to toggle the second bit of the number. So second bit is 1, and if you toggle it, it will change to 0. So after changing this 1 bit to 0, we will get this number. This is 18 in decimal. So how you can do that? How you can toggle the bit? For that you have to XOR the actual number with a number that is equal to 2 raised to power k. So if you want to toggle the fourth bit, then you have to XOR the actual number with a number that is 2 raised to power k. So if k is 4, will XOR 29 or binary equivalent of 29 with 2 raised to power 4, that is 16. So this is number 16 that I have shown over here in this slide. So when you XOR these two binary numbers, you will get this result. So as we know, if you XOR 0 and 1, you will get 1 as a result. So in case of XOR, I would like to remind you, if both the inputs are 1, the output will be 0. If both the inputs are different, the output will be 1. So when both the inputs are 0 or both the inputs are 1, in that case you will get 0 as a result. If one of the inputs is 1, other input is 0, then you will get 1 as the result. So after the XOR operation, we are getting this result. So this number is basically 20. After that, you can find it. I think this decimal is wrong. This is basically equivalent to 16 plus 13, 29. So this number is 29, resultant number, and this number is basically 13. So I have mistakenly written it wrong. So next, this number is 22. If you want to reset it, we need this number, and you have to XOR these two numbers and you will get the result. So the most important point of this is you will get a number that will be 2 raised to power k. So we are getting that number in variable b using the power function. We are finding 2 raised to power k, and through this line that is red in color, we are XORing, we are performing XOR operation on A and B. So in A we have actual number, in B we have a number that is 2 raised to power k. So when you will XOR, as I have shown in the previous slide, the kth bit will change to from 1 to 0 or from 0 to 1. I have shown the result on the next slide as well. If you input a number 45 and you want to toggle its fifth bit, then it will show you 13 as the result. So you can verify it by finding the binary equivalent of 45. This is all about today's video. I think you get it right. Thank you.